Today we will talk about extreme event and socio-economic impact in Central Africa, a CMIP-based analysis of projection. So just below we have the name of the three authors of this research paper. The first name is my name, the second name is the name of my master thesis supervisor, and the last name is the name of my tutor and mentor during my master's and at EHESP Cameroon. And I'm currently doing a PhD at EHESP in France. So, okay, so it's perfect. So as I said, climate change is the major concern facing the world today, with repercussions across all sectors and industry, and Central Africa country is no exception. Extreme events such as flood, drought, and heat wave profoundly impact all socio-economic activities in Central Africa, especially agriculture, which employs over 60% of the population. And for those who don't know the region, this sector encompasses staple crops such as cassavas, plantain, maize, and rice, as well as cash crops such as cocoa beans, coffee beans, or oil palm for export. Although this diversity offers a certain resilience against climate-related shock, the economy could considerably suffer in case of extreme changes in precipitation and temperature variation. Moreover, regional energy infrastructure is closely linked to climatic conditions. As we can see on the figure, many Central Africa countries like Cameroon, Gabon, and Republic of Congo are particularly dependent on hydroelectric sources. And this hydroelectric installation require a stable and abundant flux of water to maintain energy production. However, change in rainfall and river flows can disrupt electricity supply, affecting development in this region. And we need to pay attention on that because this event not only affect the population immediately, but have also largely impact on the environment, infrastructure, and human health with diseases such as malaria. So next slide, please. So regarding the interconnection between all those parameters, we can say that Central Africa relies on natural resources and is therefore sensitive to the impact of climate change. Next. So now we have many previous studies which generally focus on how extreme events respond to the global warming without contextualize the result within socio-economic sector. In contrast, the present study used output from 30 global climate models participating in the 6th phase of couple model intercomparison project to analyze the impact of global warming-induced changes in extreme events and their socio-economic repercussions in Central Africa. Next. So, regarding all those parameters, it's imperative for us to understand how extreme events could affect region short and long-term sustainability, helping policymakers and stakeholders to address these issues while developing adaptation and copy strategies. And this is actually the goal of our study. Next. So, to achieve this goal, first of all, we delimitate our study area based on coordinate just above the figure and subdivide the entire Central Africa in two sub-regions. In red, we have the north part, and in blue, we have the south part, called respectively CAN and CAS in this study. So now to evaluate the model and ensure its reliability to make projection over Central Africa, observed climate data were collected from 3 main sources, all at a daily stamp step. So we have 2 observational data sets, which are TAMSAT version 3.1 and SHIPS version 2 for precipitation, and one reanalysis data, era 5 for temperature. Also, to make projection, we use the ensemble mean of 30 global climate model from CMIP. And what is interesting with this latest version is that by incorporating update coupled global climate model and by introducing a new set of shared socio-economic pathway, CMIP initiates his simulation from the more recent base year. Next, based on that, we access changes in precipitation and temperature data under two SSP scenarios. So we have a low forcing scenario, which is the first scenario, 186, and the SSP 585, which is a high forcing scenario with high emission of greenhouse gases in the atmosphere. Also, future projections were evaluated by analyzing precipitation and temperature data across 3 times interval. So we have the historical period, the near future, and the far future defined as the following. Also, trend in precipitation and temperature were continuously examined from 2015 to 2100. Next. Now, as method, we use 6 extreme indices defined by the expert team on climate change and detection indices to access future daily precipitation and temperature data across Central Africa. And these indices include the consecutive dry day, consecutive wet day, simple daily intensity index, total precipitation from wet day above 95th percentile, and number of days with maximum temperature above 25 degrees Celsius and number of days with maximum temperature above 35 degrees Celsius. Next. Also, in this study, we use the Taylor diagram, which represents 3 statistical parameters: the root mean square error, the normalized root mean square difference, and the normalized standard deviation. To summarize, the statistical parameter measure of individual CMIP model and the ensemble mean in simulating all indices across the 2 sub-regions. Next. Now we will present some results because we can't present all the results of this study. First of all, we start by evaluate the model to ensure his reliability to make future projection over the region. Next. So here we have this figure which illustrates the annual cycle of daily precipitation simulated by next individual CMIP model and their ensemble mean compared to SHIPS and TIMESAT datasets across our 2 sub-regions. So here we use the standard deviation of SHIPS and TIMESAT to access observed variability and evaluate the CMIP model's ability to represent the observed climatology. Is what to notice that model falling outside the sharp gray bound of standard deviation present means that the corresponding CMIP model did not accurately capture the observed climatology. And based on that, we can say that we have better performance over CAS than CAN, with ensemble mean well aligned with observation and outperform the individual's model. But what is very important here is that ensemble mean is close to observation, whatever the subregion. And we obtain similar results for maximum temperature and minimum temperature, confirming the credibility of ensemble mean for future extreme event projection across the region. Next. So Also, as I said, we use the Taylor diagram to make this conclusion more robust. And we can see that here, ensemble mean for almost all our indices used in this study is close to observation, which confirm the previous conclusion about the credibility of CMIP model. Next. So projection obtained during this study overall present here the mean annual changes in consecutive dry day and mean annual changes in consecutive wet day. And we can say that, next, under the low forcing scenario, we will have an increase in, a decrease in dry spell is most region, except for isolated area in southern, western, and eastern boundary. Also, we should observe similar pattern in this region, but with a decrease in dry spell in region where the first scenario predict more dry spell, which means that at a low level radiative forcing compared to the high level radiative forcing, consecutive dry day will occur more rapidly. Consequently, we will have a wet spell which will uniformly decline across Central Africa. Next, in clear consensus in almost all the model for the distant future under the high forcing scenario. So next, in overall, we can say that we should have a strongest decline in northern part of our region and in the northern part of the south region, increasing with radiative forcing. Next. And here we have changes in total number of days with maximum temperature above 35 and 25 degrees Celsius. And we can say that we will have an increase in hot day across the entire Central Africa, reaching up to 41 days per year in the south part of Equator and 50 days per year in the north part with no major change over time. So we can see that here we don't have enough changes under the low radiative forcing for the near and the far future. And similar pattern should be observed under the unmitigated scenario with largest rise of hot day up to 50 days per year in the northern part of Central Africa and in the south part of Congo Basin, eventually reaching up to 155 days per year in some areas. Next. So here, as I say at the beginning, we trend in precipitation and temperature were also continuously evaluated from 2015 to 2100 to 2100. And here we have the result. In blue, we have the evolution of each indices under the high radiative forcing, and in blue, we have the evolution of each indices under the low radiative forcing, so the mitigate scenario, if we can say that. And we can say that here, this result just confirms the previous conclusion that we obtained with project changes. Next. So we have also discussed the plausible impact of this extreme event across the region. And in agricultural sector, we can say that we might have reduction in crop yield, especially for staple crop like maize, and which will increase water stress in rainfall farming, leading to agricultural failure. Next. So in health sector, this extreme event may lead to risk of heat stroke, dehydration, and spread of waterborne diseases like cholera, dysentery, and so on, caused by flood, drought, and heat wave. Next. So this extreme event also could destroy roads, bridge, and building due to flooding and landslides. And here on this picture, we have landslides in Cameroon, which is my country, just few months ago, caused by flooding. Next. Also, we could have a reduction of availability of water for local population and aquatic ecosystem due to decrease in rainfall and river flood. Next. So in the study, we propose some adaptation strategy and mitigation policies. First of all, we must strengthen infrastructure against flooding and heat wave. Secondly, we need to reinforce public health system to cope with climate-related diseases. Also, protecting and reinforcing natural ecosystem to against resilience is very important, while enhances local community resilience through education and resource management. And lastly, we could promote regional and international cooperation for mitigation and adaptation. As conclusion, we can say that we will have an intensification of extreme events across the entire region with the socio-economic impact of many activity sectors like agriculture, health, and infrastructure in Central Africa. That some recommendation can significantly reduce the severity of future extreme events and associated disaster, while strategies for adaptation and mitigation could avoid disaster and ensure the well-being of the population in this region. Next, please. So here we can finish this presentation without give some future project. So the next step will be to analyze heat wave, drought, and flow to better assess their impact on public health, particularly on children who are the most vulnerable. Next, why using deep learning techniques to identify the key driver of extreme precipitation and improve future scenario simulation. Next, and here we have the paper with a link or reference to obtain the paper. Also, if you want, you can send me an email and I will send you the paper. So thank you for your kind attention.
Great, thank you so much, Dorcas. That was an excellent presentation. I can see there's one question in the chat from Paul asking, are there any adaptation measures currently being explored as a result of your research?
Yes, of course. And here we can present all the results that we obtain because we don't have enough time. That is why at the end of the presentation, I give the paper as reference to get more information about this study.
Thank you. We've got another question where they've said, I've seen that you decided to divide your study into 2 regions. What was the reason behind it, or what clustering method was used?
Okay, we divide the region in two parts to better understand various homogeneous climatic zones across the region, because the topology of this region is very specific. And in the north part and the south part, we don't have the same homogeneity, if I can say like that in English. So that is why we subdivide this region in two parts. My English is not perfect, but I hope you understand.
Yeah, no, that was very
main
clear.
idea.
Thank you. We've got time if there's any more questions. Feel free to unmute yourself, pop your hand up, put questions in the chat. So there's a follow-up to that previous question was what clustering method was used to homogenize?
What clustering method was used to homogenize? So in my study, I just based on previous studies. So the result of previous studies during my literature review, and then I used the coordinate given in these previous reviews to select the region. So that is what I based on the topography of this region.
Thank you. And another question, this one from Shubham. Why are expected failure agriculture near future?
So as I said, for the near future, under the unmitigated scenario, which means that we will continue to increase emission of greenhouse gases in the atmosphere, which could lead to droughts or extreme flooding. This will destroy agricultural production for farming. I don't know if you get my point. And in the near future, under the unmitigated scenario here, we could have or we should have extreme event. And this is not good for agriculture in this region, especially for the north part in this region.
So yeah, a huge thank you today to both Dorcas and Pedro for both very interesting and excellent talks. We will shortly get the presentations up on YouTube so people can check back. And yeah, thank you for coming today. We really enjoyed our first seminar of the year. And keep an eye out for the announcement for our speakers for next month's seminar. Thank you very much, everybody. Not seeing any hands at the moment. If you think of anything, feel free to put it in the chat. And it can be answered during the next presentation. So thank you so much to Pedro for that great presentation.